In this lecture, we're going to discuss another matrix factorization technique, one where the measured elements in the matrix are all non-negative, and also where we want to factorize that into a product of matrices that also have non-negative entries in it. To motivate and to discuss one type of such a non-negative matrix factorization model, we're going to discuss topic modeling at a high level and LDA at a high level before we discuss two algorithms for doing non-negative matrix factorization. The motivation for models like latent Dirichlet allocation is to model text. So in these cases, we have different documents coming into us that each have different words in it, and we want to take these documents and organize them so that we group documents that discuss the similar things into similar clusters, for example, or we would want to summarize or annotate these documents, learn what's the information underlying them, what are the themes that these different documents discuss, for a variety of different tasks, either information retrieval, recommendation, prediction, etc. So for example, the idea behind topic modeling is that different documents contain words in them that belong to different thematic concepts. So for example, if we looked at a document called A Digital Shift on Health Data Swells Profits in an Industry, we have a document that discusses how the government is thinking about taking documents, health records that are written on paper, and digitizing them. And so we have words that discuss a variety of different topics. We have words like government, president, law, legislation, and bill, and lobbying that that are all kind of revolving around a political theme. We also have words that have to do with medicine, like doctors, healthcare, medical, and hospitals. That revolves around the fact that this has to do with digitizing health records. Because we're digitizing them, we have things like electronic systems and digital, which have to do with technology. And finally, because it's a lucrative, potentially lucrative business, we have words like business, economic, and companies that have to do with business. So there's one document expressing many different themes, all of them coherently put together to describe what is going on in this document. So the goal of a topic model is to model all of this information. And what we assume, starting out, is that we have a set of probability distributions on a fixed vocabulary. And each of these probability distributions have all of their probability, or almost all of their probability, on a subset of the words that all somehow belong together and coherently express a theme. So here's a toy example that I created where we might have these 5 underlying topics, where the first topic has its 4 most probable words as health, medical, disease, and hospital. And the second topic might have its 4 most probable words: team, basketball, points, and score, and so on. And if you look at any of these 5 lists, every single word in the vocabulary appears on it. So the word law appears in this sports-related list, except its probability is so small that when we order them based on probability, it appears very low in this list. So this is the idea, where each of these is a probability distribution on the exact same set of words. But if we view that probability distribution as an ordered list of words based on how probable they are, we'll see that the most probable words that come to the top all relate to the same theme. And so that we have the same, so we learn 5 different topics where each topic captures one theme underlying the data set. So this is a global thing that interacts with every document. Then for one particular document, for example, the one we previously saw, we have 2 additional things that go into making a topic model. We have first a vector of topic proportions. So for example, if we have 5 topics, then this will be a 5-dimensional probability distribution on those 5 topics, where in this case you can see that the 4 topics that appear in this document have significant probability, and the sports topic has essentially no probability for this document. So that's the first document level variable. And then we also have, for each word that appears in the document, an assignment of which of the topics it belongs to. So for example, for this word government, we color code it yellow because it belongs to the government topic, which is the yellow topic. And we have this color coding for every single word that appears in the document, saying that each word has to pick a topic that it's going to come from in this document, and it's going to be colored according to that topic. But of course, we don't have any of this information. All we have are the words contained in the documents. And so we need to learn it, and that's the inference goal of a model like LDA, which is one of the most famous topic models.